When you have a number, say I have a number 10, I find its multiples by multiplying it with the natural numbers. So 10, 20, 30. These are the multiples of 10. When I have two numbers, I find their multiples by multiplying them with natural numbers, and the multiple that is the same for both and the lowest is the least common multiple. Consider I have two numbers 36 and 90. So I have two numbers 36 and 90. I find out the LCM of these two numbers 36 and 90 using various methods. First, I do it with prime factorization. So I list down the prime factorizations of 36 and 90 vertically. So 36 least prime factor that divides this 36 and leaves no remainder is 2, and the quotient is 18. 2 times 18 is 36. Then 2 times 9 is 18. 3 times 3 is 9. And 3 times 1 is 36. Then I go for 90. Again 2 times 45 is 90. The least prime factor that divides 45, prime number that divides 45 and leaves no remainder is 5. So 5 times 9 is 45. Then I have 3 times 3 is 9 and 3 times 1 is 3. So the prime factorization of 36 is 2 times 2 times 3 times 3. And that of 90 is 2 times 5 times 3 times 3. Now I have these factors and I take one factor at a time. Which are they? They are 2, 3 and 5. And I take the highest power of these factors, each of them one at a time, in both of these prime factorizations collectively. So 2 is occurring 2 times here and once here. So I have 2 into 2. Then 3 is occurring twice here and twice here. Twice here and twice here. Which is LCM. I'm writing the answer. LCM equals this 2 times 2, then 3 twice, 3 times 3, and then 5 occurs once. So 3 times 3 times 5. So the LCM is the product of all these numbers. So it equals this is 4, this is 9, and this is 5. So it equals 4 times 9 times 5, that is 36 times 5, which equals 180. It equals 180, right? So the LCM is 180. Now this is one way of finding the LCM. The other way is I just write down the multiples of 36 and 90. I write down multiples. I multiply 36 and 90 with the natural numbers. So 36 times 2 is 72. 36 times 3 is 108. 36 times 4 is 144. 36 times 5 is 180. 36 times 6 is 216. Then that of 90 are 90 times 2 is 180, and then 90 times 3 is 270. And here I have a common multiple which is the lowest. Here 90 times 2 and 36 times 5. So this is least common multiple. The multiples I find out, and the lowest multiple which is common is the least common multiple, which is equal to 180. Next, I try to find out the least common multiple using the common division method. So I have used the same method for finding out the HCF, but now for LCM, we have to do more steps than HCF. I write down both the numbers together, and the prime number which divides both without a remainder is 2. 2 times 18, the quotient is 18 when I divide 36 by 2, and 45 is the next number. Then I don't have 3. I don't have 2 then. I have the prime number that divides these two together. It is equal to 3. Equal to 3. 3 times 6 and 3 times 15. Then I have again 3. 3 times 2 and 3 times 5. Then there is no prime number beyond this common 2. These two themselves are prime numbers. So here in the HCF, we used to stop at this step. We used to stop at this step and we used to say that the product of these three numbers on the left, it's the HCF. But LCM, we go beyond this step, and again I write down 2. 2 times 1 is 2, and 5 I write down as it is. Then 5 times this 1 I write down as it is, and 5 times 1 is 1. So I have 1 and 1 in the end, which is the last step, and the LCM is the multiplication of these numbers, which equals 180. So, and yeah, this is the last step. The last step in finding out the GCD was here, 2 times 3 times 3, because 2 and 5 were co-prime, right? But here we go one step ahead, and 1 1 we have at the last step. Okay, now we can also find out by one more way the LCM. We have a formula. We have a formula, which is the formula product of numbers equals least common multiple times highest common divisor or times GCD. What is the GCD of these two numbers? It equals here, I mean the GCD of 36 and 90. So the common factors are 2 and 2 and 3 and 3 and 3 and 3. So 2 times 3 times 3, which is equal to GCD of these two numbers is equal to 18, which is 2 times 3 times 3, 9 times 2, right? So it equals 18. So what is the product of numbers? I can write down the product of numbers as 36 times 90. And here LCM is the unknown times the highest common factor, which is 18. So therefore, I rearrange LCM equals across, I bring 18 to the other side. 36 times 90 divided by 18. And I cancel off the common factors. 18 goes twice in 36. So the LCM is 2 times 90, which is equal to 180. This was the various ways of finding out the LCM of two numbers. So next I continue. The next part is that how do I find out the LCM of three numbers? So earlier up till now I have found out the LCM of two numbers together, but now I consider three numbers and I do it with the common division method. So I write down the three numbers together. Common division method I'm doing. So the numbers are 30, 105 and 420. So two of these numbers are even, that is 30 and 420. As they end, units place is 0, right? But 105, the units place is an odd number, so it is not even. So since one number is odd, I cannot put 2 here as a common prime number that divides the three numbers. So I have to consider the next prime number, which is 3. And 3 divides 30 without a remainder. 105, the sum of digits is 1 plus 5, which equals 6. So the sum of digits is divisible by 3. So therefore 3 divides 105 without a remainder. Also in 420, the sum of digits is 4 plus 2. That is again 6. So it is divisible. 6 is divisible by 3. So 420 is divisible by 3. And there is no remainder. So I put 3 here as the common prime number that divides these three numbers. When I divide 30 by 3, the quotient is 10. So I write down the quotient. When I divide 105 by 3, the quotient is 35. And when I divide 420 by 3, the quotient is 140. Then the next prime number that divides these three and leaves no remainder is 5. 5 times 2 is 10. 5 times 7 is 35. And 5 times 28 is 140. Then I consider the next lower prime number, which is 2. And I write 1. 7 I write as it is. 14 times 2 is 28. So I write 14. Then I consider again 2, since 14 is still divisible by 2. I write 1 as it is, 7 as it is, and 14 times 7 is 2. Then 7 is the last. 1 times, that 1 is written as it is, and 7 becomes 1, and this becomes 1, right? So what will be the LCM? LCM will be the product of these prime numbers which I have on the left hand side. So LCM equals 3 times 5 times 2 times 2 times 7. So it is like I'm multiplying 3 and 5, which is 15. 15 times this is 4 times 7. So 15 times 4 is equal to 60, and 60 times 7, which is equal to 420. So the LCM is equal to 420. Next, I do some real life application sums in LCM. So in the last video of HCF, you learnt a real world application sum of HCF, and you have two numbers there, and you find the greatest number which can divide both and leave a remainder. So the number divides the two numbers, so it is a divisor and it is the greatest common divisor. Now you learn the other way around for application of LCM, which is the smallest number which when divided by 22 and 88, in each case leaves remainder 6. So it is divided by 22 and 88. Since it is divided by 22 and 88, so it's a multiple of 22 and 88, and it leaves remainder 6. So basically it is the lowest, smallest number means lowest. So it is the lowest common multiple. So I write down the prime factorization of 22. 22 equals 2 times 11, and 88 equals 8 times 11. So LCM equals 2 times 8 times 11, which equals 16 times 11. So this equals 176. And when divided by 22 and 88 leaves remainder 6. So it is a least common multiple. It is divided by 22 and 88, leaves remainder 6. So final answer is not 176, but it is 176 plus 6, which equals 182. So 182 I divide by 22 and 88. In both the cases it leaves remainder 6. So this is the answer. The next sum is, I'll just read it out. I make two necklaces, and in the first I add a necklace separator after every 4 beads. And in the second I add a necklace separator after every 6 beads. So how many beads should be there in each necklace so that the number of beads are the same? So I just make the first necklace. 4 beads and then a separator. Then again 4 beads. After every 4 beads I add a separator in the first. And in the second I add a separator after 6 beads. So I'm adding here after 4 beads. I'm here adding here after 6 beads. So how many beads should be there in both the necklaces? Common number of beads. I mean, both should be equal number of beads, so that such that I add 4 after every 4 in this, and I add after every 6 in these. Both should be equal. So that is the LCM of 4 and 6. 4 equals 2 times 2. 6 equals 2 times 3. So LCM is equal to 2 times 2 times 2 times 2 times 3, which equals 12. So here I will add 12 beads. This is a separator, this is a separator, this is a separator, and these are beads. So 12 beads in this, and this is the second separator, and 12 beads in this. So the beads are equal, such that here I add a separator after 4 beads, and here I add a separator after 6 beads. Thanks for watching.